Can we also make a test bench for noise with LTspice? Yes, we can. Here I have some test bench with biasing and the antenna. So here we have the E field. V1 represents the E field. E1 represents the antenna gain. So that is, the gain is LA, the length of the antenna. C1 is the antenna capacitance. Oh, I'm sorry, we just appeared too immediately. I didn't upload the latest version, I see. Then we have a gate bias resistor, R1. And this is tricky because this is a resistor. So this is a noisy element and it does multiple things in this way of biasing. It also sets the cutoff frequency at the low side, and that is not just given by RC. It also has to do with the loop gain in the bias circuitry. So if you make a E2 to have a very high gain, then your low frequency cutoff will be far above 100 kilohertz, and you cannot have reliable noise results below that frequency because this is not what you want. So you can check the AC performance of this circuit first before you start doing the noise. So this E2 is the bias controller, the drain current bias source, the drain voltage bias source, the CS stage itself, and that out is the summing node for the noise. Spice sums all the noise contributions to out, and if you want to have the equivalent input noise, it divides these noise contributions by the gain from the source to that node, exactly as SlideCap does as well. So this is the test bench, but you always have to check for correct operating point first. If the thing is not converging and you have not the desired VDS voltage at the drain, then you can, of course, forget about the validity of your noise results. And what I forget to mention, using a circuit like this, you also have to check for the frequency response at the low side. The high side is not interesting at all, but the low side is limited by the resistor here that is also noisy.